Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. We've seen the intuition, the formula, and the path diagram for omitted variable bias. Now let's put numbers and compute the bias explicitly. By the end of this video, you should be able to quantify the omitted variable bias from first principles, just from knowing the true model and the correlation structure. So suppose that the true model that we're starting off, we defined it in the previous video as y being equal to gamma 0 plus gamma 1 x plus gamma 2 z plus an error term u. Let's assume that at this stage we have estimated y as equal to 2 plus 1.5x plus 2z. So what we see in here is that we've got the true effect of x, which is the 1.5, and we've got the true effect of z. So at the moment, based on the true model, what we have put into our path diagram is a y and x and a z, and we know this arrow exists and we know this arrow exists. However, we know at the same time that x and z are correlated to each other as well. So the moment that we are going to estimate the bias model, something is going to go wrong, okay? So we know that this relationship exists, and we also know that it was the auxiliary regression or the auxiliary model that gave us that information. In the previous video, we wrote that simply as z being equal to alpha 0 plus alpha 1x plus an error term. So let's assume for a moment that we have estimated here z hat being equal to 1 plus 0.5x. Okay, so what we are seeing in here, this positive 0.5, is just saying ability, since x was for education, is positively correlated with ability, okay? So basically for every additional unit of education, ability tends to be 0.5 units higher, whatever the units of that we're using in here. Also, keep in mind, this alpha 0.5 is that alpha 1, and at the same time, this 0.5 is literally the covariance of x and z divided by the variance of x. Okay, so just using again the definitions of a beta in general, because this auxiliary regression coefficient, it's the slope from regressing z on x. Okay. So it connects the correlation structure directly to the bias. So at this stage, we know that this is my alpha 1, which is the 0.5. From the true model, I already know that my gamma 2 is right here, and it's the number 2, the coefficient that I had in front of z. So based on the information that you have from the previous video on the path diagram, you already know that you would have overestimated the model if you had omitted the z variable, because gamma 2 here is positive and alpha 1 in here is also positive, which would mean that overall you have gamma 2 times alpha 1, which is positive. So you should have had an overestimation. Now, the bias model, so let's do the last bit. The biased model, which in the previous video we wrote as something like y being equal to beta 0 plus beta 1x plus an error term, this would have been overestimated, okay? The thing is, we know this beta 1 in here, this is not going to be the 1.5 that we actually found up here, okay? Because we know that there is a relationship between z and x, and that needs to be taken into consideration. So what is the formula going to be in this case, or what is the magnitude going to be? Well, we know that this beta 1 in here is going to be equal to whatever like the true value should have been, plus the bias, which we know the bias is the gamma 2 times the covariance of x and z divided by the variance of x. Okay, and right now we have all of that information. So we have gamma 1, which is simply 1.5, and then we've got the gamma 2 from also the true model, which is exactly 2, and then we've got the covariance here, which is the alpha 1, that we found is simply 0.5. So normally the beta 1 that we have in here, if we had estimated it, we should have found it to be 2.5. Okay, so the true effect was 1.5. The moment that we omit this z variable, the beta 1 shows to be 2.5, which means we are overestimating. Okay? So we are clearly overestimating. We already knew that we would have overestimated it based on the signs of the two coefficients that we estimated in here. Now we also know by how much. Okay, so by 1 unit in here. So the estimated coefficient 2.5, the true effect 1.5. And that means that we are actually attributing too much to education, because part of what we're calling the education effect, it's just the ability effect. Okay, so the entire unit of bias in here is coming from ability, a variable we never included in here. You can also do and verify both approaches if you want. So you could start from having the bias model and getting to the actual true model, in which case you would have had, well, an estimation of 2.5, then minus the 2 times 0.5 to get the true value of 1.5. So usually, most of the times you will know the bias model and the auxiliary model, from which case you can find the true model. So be aware that the same way that you can write here beta 1 equals to gamma 1 plus gamma 2 times the bias, you can rewrite this as gamma 1 being equal to beta 1 minus gamma 2 alpha 1. Okay? So that shouldn't really throw you off overall. So overall, the size of the bias depends on how important Z is, so our gamma 2, and how big or small, strong or weak is the correlation between X and Z, meaning this alpha 1 that we have in here. A large gamma 2 and a strong correlation usually means a large bias, and a small gamma 2 with a weak correlation will mean you have a small bias. This is also why researchers worry most about omitted variable bias that are both highly relevant and highly correlated with their variables of interest. And now that you have the formula, you can get also a sense by yourself why that is important. So omitted variable bias changes the estimated coefficient by gamma 2 times alpha 1. So the bias is larger when the omitted variable is more important and more correlated with the X. I hope this was helpful, and I'll see you in the next video.